Good evening, friends, and welcome to interview preparation session. So yesterday we discussed some basic questions on Python. Today we'll be going to some basic questions in data science. Okay, so data science. So let us take the first question. First question is, what is data science? So you can put your answers in the chat. I'll be checking. Okay, so data science we can say is an interdisciplinary field. Okay, it is an interdisciplinary field, means it comprises of different fields. So statistics is involved. Okay, now maths is involved, probability that those are statistics only. Engineering is involved, and so if we are dealing with financial data, finance is involved. So different different fields are involved in this. So it is known as interdisciplinary field. Okay, it is an interdisciplinary field that uses scientific methods. Okay, it uses scientific methods, processes, and algorithms to extract knowledge and insights from data. Now, this data can be structured or unstructured. It might be having noise, or it might be clean data. Okay, so we can draw knowledge, or we can extract knowledge or insights from these datas. Okay, and this insights or knowledge can be applied, means it can be used to make decisions on a you can say, and the data we can say is used on a broad range of application. So it has a broad range of application. So so I'm just telling you all together. So data science is an interdisciplinary field that uses scientific methods or processes or algorithms to extract knowledge and insights from data, which can be structured or unstructured, having noise. Okay, and use this knowledge and this insights. Okay, and apply this knowledge and insights, actionable insights you can say, from the data across a broad range of application domains. Okay, so these insights can be used to make decisions on a broad range of applications. Now, taking the second one, why is data science so popular? So nowadays we are saying everyone is saying this is the job of the future. Okay, so why is it so popular? Yeah, so why is it popular? Okay, so the reason why data science is so popular is because of the insights or knowledge that we can gain from this data, noisy or clean, whatever, structured or unstructured. Okay, so from this data, the knowledge which we extract and the insights which we gain, okay, these has led to some of the major innovations in this present years. Okay, so these insights, uh, so using these insights, we were able to, you can say, uh, make great decisions, and that is why it has become so popular. Now, coming to the next one, why is no? What is the difference between data science and traditional program? So what is the difference between data science and traditional program? So today we'll just be discussing basics only in data science. So what is the difference between data science and traditional programming? Okay, in traditional program, okay, okay, in traditional program, we have the input, we have the input data, okay, and we know the expected output. So to get that expected output, we write some rules. Okay. And by this, we get our expected output. But in DS, what happens? Just a second. We know our input. Also, we know our output. So we have our input also, output also. Okay. The thing we find out here is the rules, or in other words, you can say patterns in the data. Okay. So in traditional programming, we had the input, we wrote the rules. Okay. According to that, we got our output. But in DS, we are having input data. Also, we are having output data. Okay. So we just find out what is this mapping to input and output. So this mapping is nothing but these rules. Okay. These rules or these patterns which contain the information uh, as to how from this input we are getting this output. Okay. We are finding that in DS, data science. Okay. Now coming to next question. What is machine learning? What is machine learning? So let me just write here. Okay. What is machine learning? So this I just added. Data science, 3 points I've added. Interdisciplinary field, extract knowledge and insights from data, and use this data to make decision. Next, what is machine learning? Okay. So machine learning, we can say it is a uh, subset of artificial intelligence. Okay. So machine learning is a subset of artificial intelligence. Okay. And here, without doing any explicit programming, okay, without doing any explicit programming, we can find the rules or these patterns which we discussed now. We can find those patterns using this uh, machine learning. So in other terms, if I say it is a type of artificial intelligence, okay, which by which we can you can say find out rules or patterns uh, hidden in the data. We can tell like that. And here explicit programming is not needed, so everything is there. We just need to call the algorithm, means machine learning algorithm, and it will do the work on its own. Next, what is deep learning? What is deep learning? Okay, now deep learning. So deep learning, we can say it is okay, yeah. Deep learning, we can say it is a machine learning method in which we use neural networks. Okay. Now, what are neural networks? So these neural networks are used to imitate structure of a human brain. Okay. So just like how the human brain learns from information, okay, machines are also made to learn from the information that is provided to them using this neural networks. So basically you can say deep learning is a method in which uh, the system tries to imitate the structure of a human brain. So how human brain processes information, it tries to mimic that operation, you can say. Now coming to next question. What is confusion matrix? What is confusion matrix? Okay. So this confusion matrix is represented as a 2 by 2 matrix. Okay. Where we can predict if our, so this is basically a evaluation metric. Okay. Here we can estimate the performance of a model. Okay. So what is the structure? Let me just show you. So suppose we are having 2 by 2 matrix. So here, suppose we are having the actual value. Okay, so it predicts actual value in respect to the predicted value. Suppose these are our predicted value, these are our actual value. Okay, so this is suppose we are having two class, positive, negative, or 1 0, you can say. This is also positive, this is negative. Okay, so this matrix will show us the values where suppose this actual is 1. So suppose actual is positive and this prediction is also positive. So this is the place where the value will be recorded, and this place is known as true positive. Okay, in this matrix, whatever value is here is known as true positive. Means it's whatever value is supposed to be in our prediction also we are getting the same value. So this is known as true positive. Again, if the actual value is negative, okay, but our prediction is showing positive, then those values are known as false positive. Okay, if actual is negative and prediction is positive, those are known as false positive. Now same thing in negative also. So if our value is our actual value is something and we are not getting the same thing here in for this n values. So just take values like 1s and 0, suppose two class we are having. Okay, this is 1, this is 0. So suppose we are having one value for both actual and prediction, it is true positive. And suppose for actual we are having 0, but for prediction we are having 1, that is false positive. And for actual, if we are having 1 and prediction we are having 0, that is known as false negative. Okay. And here, if for actual we are having 0 and also for prediction we are having 0, it is known as true negative. Okay, so this is a confusion matrix. So by this we can calculate many things. So we'll be seeing all those now. Okay. So let us go to the next question. What are the different evaluation? What are the different evaluation measures that can be found out from confusion matrix? Okay, so what all uh, evaluation measures can we find using this confusion matrix? So these values, using these values, what all evaluation measures we can find? Okay. So first one is error rate. Error rate. Then we are having accuracy. Okay. So one thing to remember, guys, this is confusion matrix is for classification. Okay. So error rate, accuracy, uh, precision, recall, uh, precision, recall. I think specificity and one more. Yeah, false positive. Okay, now this recall is also known as uh, sensitivity. Recall is also known as sensitivity, and uh, yeah, I think that is it. So let us go through them one by one. So first, from this, first one is error rate. So next question, let us take what is error rate? So what is error rate? Yeah. So what is error rate? Okay, error rate is like error by total number of data, or you can say, yeah, total data. So error data by total data, you can say. Now for from this, if we check what is error data is nothing but uh, our false predictions. So false positive plus false negative, right? Okay. Before this, let us consider this total data is addition of all data. So let us take this as TD. TD is false positive, okay, true positive plus true negative plus false positive plus false negative. Okay. So error data is like, sorry, error rate is like FP plus FN, which is our error data. Okay, by this total data. Okay, this is the error rate. Next, what is next was accuracy. What is accuracy? Okay, accuracy is just the opposite of error rate. Accuracy is correct data, or you can say correct predicted data, correct data only, divided by total data. Okay, now what is this correct data? Correct data is like all true data. Okay, so correct data is true positive plus true negative. Okay, accuracy is equals to this divided by total data. Now next is precision. Precision. What is precision? Okay, this precision is like total, or you can say number of positive, true positive prediction, number of true positive prediction by total positive predictions. Okay, if I go to the formula, it will be in terms of this true positive, true negative. Number of true positive prediction is true positives divided by total number of positive prediction is true positive plus false positive. Okay, so this is precision. After precision, we are having recall. So what is recall now? What is recall? Okay, so recall is like number of positive predictions, true positive predictions. So let me just write the formula directly. Number of true positive prediction, which is TP, okay, divided by total number of positives. Okay, so here is total positive prediction, but here we are having total number of positive. So total number of positive like true positive plus false negative. So false negative and true positive is total positive. Okay, recall is this, or you can say recall is also called as sensitivity. Okay, so total number of true positive by total number of positive. The total number of positive is true positive plus false negative. But precision is total number of true prediction by total number of positive prediction. So positive prediction is like true positive plus false positive also. Now coming to next we are having specificity. So next, what is specificity? What is specificity? So it is like uh, it is like number of negative predicted value. Okay, so true negative by total number of negatives, which is true negative plus false positive. Okay, this is specificity. Total number of negative predictions. Uh, no, total number of correct negative predictions by total number of negatives. Okay, so this is specificity. Last, what is last we have a false positive rate. What is false positive rate? Okay, now false positive rate. Yeah, false positive rate is like number of incorrect positive. So false positive rate is number of incorrect positive, which is false positive, divided by uh, divided by total number of negatives, which is true negative plus false positive. Now this is called false positive rate. We also have something known as true positive rate. Okay, so what is that? Let us know. What is true positive rate? So recall. Okay, recall is also known as true positive rate. Okay, or also sensitivity. Also, we have something known as true negative rate. Okay, so this specificity is known as true positive rate. Sorry, true negative rate. Okay, true negative rate. And did I miss out anything? Yeah, and predict this precision is also known as uh, precision. Yeah, precision is also known as positive prediction value. Okay, this may be asked like, what is the formula for positive prediction value? So you will need to give this formula. Okay, for precision. So you need to remember. Okay, error rate is total number of error in the data by total data. Accuracy is total number of correct data by total data. Precision or positive prediction value. Okay, these are like total positive by total positive plus sorry, true positive by true positive plus false positive. Recall or a true positive rate. Okay, I'm not written right here. True positive rate or sensitivity. Okay, these are three names for the same thing. It is like true positive by true positive plus false negative. Now what is specificity? It, or you can also say true negative rate. So it is true negative by true negative plus false positive. Now what is false positive rate? It is false positive by true negative plus false positive. Okay, now coming to next question. Okay, next is what are the various libraries? What are the various libraries we will be using for data science? not various, we can say what are the general libraries. Okay. Generally, which all libraries will be using for data science is the question. What are the general libraries to be used for data science? Okay, what are the general libraries to be used for data science? Okay. So this will be the last question for today. So let us go through the different libraries. So first off, we are having NumPy libraries. NumPy library. Just write NumPy. Okay. So these NumPy libraries are used for mathematical and scientific computations. Okay. Mathematical and scientific computations. Okay. Second, we are having Pandas library. Okay. Now this Pandas library is used for data manipulation. Data manipulation and analysis. You can say. Yeah. Next up, we are having. Okay. So also one thing to note here for Pandas. Okay, it provides various features like you can say handling of missing data, then indexing, different kinds of indexing. Okay, data alignment, all those things we are having in Pandas. Apart from this, we are having a library called matplotlib. Matplotlib. Okay, this library gives us you can say mainly used for visualizations. Okay, matplotlib also the same thing we can do using Seaborn. Okay, Seaborn gives us, in my view, it gives us better visualizations. Apart from this, okay, we are having SciPy library. which is also you can say scientific Python. Okay, so here we have various you can say scientific library. So here we have functionalities on complex maths, okay, complex mathematics, also science and engineering problems. Okay. Then we are having uh, sklearn or scikit-learn, you can say. Scikit-learn library. Okay. It has this basically contains all the algorithms for classification, regression, clustering. All those algorithms are present in this library. So classification, regression, and clustering functionalities are present in this library. Okay. Apart from this, we also have a stats model library. Okay. These we can say are part of scientific, uh, basically all the statistics parts it contains. Okay, so you can say data analysis and statistics. Apart from this, we also have Keras, Keras library. Okay, so Keras gives us an interface for TensorFlow library. Okay, here you can say it is used to train our deep neural networks. Okay, used for deep neural networks. Okay, I think these are the basic models. Also, we are having TensorFlow. Okay, TensorFlow also used for this neural networks. Okay, these are the basic libraries which uh, you will be using when doing the data science tasks. Okay, with this, we can just end our session today. And we'll be moving to our data science more deep in data science tomorrow. So these were the basic questions. We'll be diving deep tomorrow. So yeah, thank you everyone. Have a good day.